Now that you understand that behind the green and digital transition there are metals, now that you understand that there are impacts behind mining, let's speak about the solutions. A first group of solutions relies in our behavior. Some people will speak about degrowth. Some people will speak about overconsumption. There is a debate here between the economists. Let me just give you a few facts. The CO2 emissions has decreased 3 times over the 30 last years. It was at the collapse of the Soviet Union, it was in the 2008 during the economic crisis, and this was during the COVID. What does it tell us? It tells us that there is a correlation between the GDP and the CO2 emission. But it also tells us that when the GDP decreased in an uncontrolled manner, then there is also high social impact that we have to take into account. So today, the question is more, how can we redefine our economy so that the GDP is not correlated with the use of natural resources? And here it also brings us to the question of our individual behavior. We sometimes see electric scooter thrown in the river or being disposed as single-use things. This is really a question for all of us. Behind all those devices, there is metals. And behind the metals, there is mining and their impacts that we have discussed. So we should, as citizens, also wonder, what do we really need? And also be refusing obsolescence and the overconsumption. This is a way also as individuals to reduce the CO2. So this has an impact. But we should see this solution as a cocktail of a sum of different solutions that will have an impact. The second family of solution is called circular economy. So in circular economy, we sometimes see recycling. And there is a lot of truth in this, because recycling, especially the metals, is a way to decrease drastically the CO2 emission. We see that the CO2 emission, for example, of steel, which is, I remind you, 7.2% of the world emission, can go from 2 kilograms per kilo all the way down to 0.7. This is about dividing by 3. So you understand the impact it may have to recycle all the steel. But before recycling, we could also think about extending the lifetime of the product, because as soon as the device works, it doesn't emit CO2, while recycling will emit CO2, much less than mining, but a non-zero quantity. We could also think about repairing. This is also very low CO2 emitting solution. But then it is also a new challenge for the engineers, how to design new devices so that they are easy to repair. There is a lot of fascinating research, both in engineering, but also in social science and in economics, to solve this type of problem. The third group of solution is substitution. So we understood some metals are extremely critical, either because they emit a lot of CO2, either because they are produced in small amount, or because their production is concentrated over only a few countries. So this may be creating problems. But there is actually a good news. The number of alloys possible is absolutely huge. Look at this graph. If you look at the alloys containing 5 different elements, with a concentration step of 1%, you have 10 to the power 12, 1,000 billion of possibility. This is comparable with the number of galaxies in the universe. And if you go to the denary alloys, that means the alloys containing 10 elements, with a compositional step of 1%, then you reach 10 to the power 25. That is the number of stars of the universe. So this is a truly astronomical number. So then, most of these alloys will be uninteresting, but a few of them will be extremely important and could potentially replace the metals that are the most critical. Because yes, that's the magic of metallurgy. By mixing a few metals, you can create alloys that outperform the elements taken alone. And this would be an interesting strategy, particularly for hydrogen, but for many other applications, to reduce our dependence on the most critical, or on the rarest, or on the dirtiest metals. But this requires a huge investment in research, and a research guided by sustainability. So this is the end of our module. I hope now you are convinced that metals and green transition is a fascinating topic. I also want you to be convinced that this is not only a matter of metallurgists. We need many people from many fields. We need economists to do research and find a new economic model. We need policymakers to implement that in our societies. Of course, we need engineers that will find a solution to reduce the impact of mining, to implement the circular economy, or to find the new materials. And of course, we need research. We need research in energy systems. We need research in metallurgy to basically discover the materials of tomorrow, so that eventually together we manage to solve this equation.